Hello and welcome to the second hour of our 24-hour Macroscopes interactive data visualizations. We are getting set up here, getting our panelists online and making sure folks are ready to go. I see that we have both Joe Heimlich and Kylie Peppler here on the call. And we're looking for Stephen Uzzo, and I'm wondering if perhaps you're on with a different name. So if you are, Stephen, let me know and I'll promote you to panelists so you can join us for the discussion. Let's see. So Joe and Kylie, are you both able to unmute and speak, or do you?
Yes, I'm able
Great.
to.
Wonderful, Joe. Thank you. It's good to see you today, or to hear you in any case.
Hi, Lisel. Hi, Joe. This is Kylie, and I'm able to speak as well.
Hi, Kylie.
Great.
Welcome. Let's see. I do not currently see Joe or see Stephen online. So I think what we'll do is we'll go ahead, we'll get started, and that will give us an opportunity to begin with Joe and then go to Kylie. And then if we have, if Stephen is able to join us, we will add him to the call at the end. So for this hour, our topic is macroscopes in public places. And we have a group of really highly experienced folks for working with informal learning and working in some of the spaces that here in our university setting we don't always work with so often. So we're going to talk more about macroscopes and how they operate in places like museums, possibly parks or science centers, libraries. There are lots of places where learning happens that's not in a classroom. And so we'll be talking a little bit more about what kinds of opportunities there might be for macroscopes in public places, and hear a little bit more about some of the work that each of our panelists has done in that arena. So I'm going to just do some brief introductions, and then I think without further ado, we'll jump in and start with Joe. So our three panelists today. Stephen Uzzo is the Chief Technology Officer at the National Museum of Mathematics. He's also was formerly at the New York Hall of Science. And he develops and leads large-scale initiatives to integrate cutting-edge science and technology into teaching and learning. So that intersection of technology and learning, which is really a common theme of all of our panelists today. His research interests include complex networks, teaching and learning of data-driven STEM, and the impact of big data on teaching and learning. And then our second panelist today is Joe Heimlich, who is a Senior Director of Research at the Center of Science and Industry's Center for Research and Evaluation. He's also a Professor Emeritus with The Ohio State University and a past president of NAAEE and the Visitor Studies Association. Joe studies how people learn in non-formal, informal, incidental, and everyday settings. And Joe, maybe you can tell us about what the difference is between all of those later on. And he's now best known for his work in learning theory, research, and evaluation. And our third panelist today is Kylie Peppler, who is a professor of both informatics and education at the University of California, Irvine. She's also the director of the Creativity Labs and co-director of the Connected Learning Lab. Kylie engages in research that focuses on the design of new technologies to support learning and participation within traditionally minoritized populations, particularly at the intersection of the arts and STEM learning ecosystems. So welcome, and thank you all for joining us today. We will be talking about a range of different projects, including one that we worked on together that had to do with trying to bring data visualization into museum settings. So without further ado, I think we're going to jump ahead, Joe, and I'll let you get started. Would you prefer to share your own slides, or would you like me to share them and you can let me know when to advance? Either one is fine.
Why don't you just keep it on your screen? That way we
Okay.
won't play around. And thank you very much. Hi, Lisel. Hi, Kylie. Hi, Kadi. I'm going to share with you a journey of 2 NSF projects that Kadi led us through. And the idea was starting with big data and how to be integrated into museum settings. And that moved into the macroscope and how do we get that in a museum? And then we realized just because we can do this stuff, should we? So I'm going to share with you a series of studies that we led over several years to try to answer some important questions. Go ahead and change. So we saw great opportunity, data visualization literacy in the museum. We could see greater engaged visitors, increased hold time, integrating experiences and learning in new ways. But the potential challenges were what my team got to focus on. What can we say? How far can we go? How should it look? What personal data are visitors willing to share? And with whom? If we're going to be talking about them and comparing them to other people, what do we need to know? With whom would they compare themselves? How honest are visual critiques? Is the macroscope transferable? So those are the questions that sort of drove my work and my team's work as we helped moved alongside Kadi. And go ahead. So what did we do? We did a lot of different kinds of studies. We did construction, deconstruction studies of visuals, map comparisons, social comparison study, observations, intercept interviews, intercept questionnaires, transferability study, a lot of different tools we used to try to understand the tool of the macroscope and the visitor experience. As we move on to the next slide, what did we do? It was about the familiarity with the language. We found, of course, what was found over and over in other studies by other people. There's a definite lack in understanding big data. Most people have no strong recall of what big data is or could be. But people were better understanding data visualization. They were able to understand that concept more easily than big data. And we did find a fascinating thing that when people talked about big data, it was used not with the same meaning as within the academic setting and the more scientific meaning of big data. The next thing we wanted to look at was understanding complex visualizations. How far can we go? So we took 20 visualizations. These covered all sorts of types of maps and visuals and graphics. We learned a whole lot from this. First, age factors into recognition of visuals. The older the person, the more familiar they were with a lot more types of data viz. What was surprising, given widespread data visualizations are in the media, that people seem to say school was the place they really saw visuals used and gain meaning from. Of course, colors, objects, size, all are key aspects for how people interpreted the visuals that they were looking at. And very few responded correctly naming the types of visuals that they were looking at. And then as similarly, contrary to widespread use, data viz literacy is very low for both youth and adults. They think they understand them until they try to explain them, and then we find out really interesting problems with how people make meaning of data visualizations. One of the fun things was making visualizations meaningful. How should visualization be revealed? So visitors have very low familiarity with specialized data. Not a big surprise. Visualizations with more than average complexity, more than 2 axes, are very difficult for people to quickly assimilate and understand. Museums assume there's a greater familiarity and understanding than does exist in the visitor. There's a lot of information, a lot of visual information in museums, and people don't understand a lot of the visuals. We did learn we need to provide supports and scaffolding for understanding visualizations, and that constructionism is more important than constructivism for data visualization. Actually starting with the base and adding layers slowly helped people understand the complexity in some of these visualizations. If we started with a complex visual, they would set in their mind a very specific, this is what this visual is about. And they would hold on to it even as we got to the first base axis. They still held on to what they thought they saw at the beginning. From this study, we developed a simplicity familiarity matrix that we use in determining the level of scaffolding that is needed. Then we wanted to say, what would people want to know? What would people want to know about themselves? What personal data are visitors willing to share with and whom? This is actually a very big question that's been asked in city and regional planning, in museums and visitor studies. How far are people willing to go with what they share about themselves? We found two areas that were a little more on the edges of sensitivity. The first was medical information. People were less likely to want to be willing to share anything about their medical conditions. And also the closest intersection to their residence. They don't want you to know where they live. There's far less sensitivity on weight, sexual orientation, physical activity, age, religion, a host of things. People weren't really afraid of sharing, but they want to do so privately. They preferred paper and pen for questionnaires, or a secondary preference for interviews, but the interviews would need to be given in private settings. So they're willing to share the data, they just don't want other people to hear it. So the older respondents and females in general have less comfort in sharing data about themselves than younger and male respondents, which is not terribly surprising. Then we asked, what is compelling? With whom would visitors want to compare themselves? They're going to be comparing, we want to make sure we have the right contrast. So what we did was we asked a lot of visitors a lot of questions about comparing themselves to others. And we used social role theory in this. We found broader options were preferred. A lot of different people wanted a lot of different people to compare with in different ways. The problem is, in this setting, there's a time limitation. People are not willing to enter a lot of data about themselves to be able to have it compared. So the issue of how do we get the data from a visitor so that they could then compare themselves to others is problematic. We also learned the current social role a person is enacting drives the interest in with whom they're willing to compare or want to compare. It means if I'm there with children, I'm in a very different role than if I'm there with friends. And that's really different than if I'm there with professional colleagues. So who you are, the role you're enacting, did change dramatically who people were wanting to compare themselves against. And we did see that interest with whom varies by age, gender, and target attribute, but not any one group of people have a certain specific compelling component. And so then, the conclusion. Oh, yeah, how honest are critiques? Sorry about that. We did look at willingness of people to give us good feedback, critical feedback. We used hand versus computer maps, and we had 3 degrees of doneness, from a sketch to a fairly complete visual to a very well done hand drawn or computer driven created map. Most effective, computer low quality. People were willing to tear it apart when it was a low quality computer production. Least effective was the high quality computer visual. We did learn that more educated people are, the more likely they are to offer a critique. Hand-drawn and carefully drawn are more likely to have positive comments than negative comments. And being in a group increased the likelihood of offering critique. In other words, people don't want to give you a critique on something that looks finished. It feels like it's wasting their time. They want to see it more than a rough draft, but they don't want to see a finished product. And from there, Can the macroscope be distributed? Is it possible to take this idea, this activity that Kadi and her team were creating, and transfer it to other physical experiences where a person engages in an activity and it captures data about that activity and compares them to others on different attributes. So we observed visitors at 3 types of physical interactives. We did intercepts with those who engaged, and we did some with those who did and did not engage within groups. We did several things we learned. 1, activity needs to fit in with the larger exhibit context. It needs to be part of the bigger experience. And it needs to be intuitive about the action required. People want to jump right into the activity. They don't want to have preparation and have to do reading before they engage in the physical activity. The data input needs to align with the action being requested. So if we're asking them questions about themselves to be able to compare on different dimensions, those data need to somehow tie sociologically into that physical experience activity. And ultimately, we need a natural flow from the engagement to the activity to the data visualization. We saw a lot of moments when there was a break in the flow, and that's when people disengaged. So in conclusion, on this journey, what did we learn? Well, we learned a lot, and we learned there's a lot more to learn. Thank you very much for your time. And I do have a slide with some of the citations from the work that we did. Thanks.
Thank you, Joe.
Thanks, Joe. Let's see. Kylie, would you prefer to present your slides, or would you prefer to have me forward you through the slide deck?
Go ahead and present the slides, and I think it'll be kind of natural when to progress, but I'll let you know.
Okay.
Thank you.
Sounds good. Let's see.
So my name is Dr. Kylie Peppler, and I'm here at UCI, but this is a project that I'm going to be sharing that was a collaboration between Joe and Stephen and Kadi and Lisel and the full team. And my expertise is really as a learning scientist. So I study how people learn in a variety of settings. And what was really captivating to me, with the macroscopes was really just trying to understand how people can start to make inroads to break down, big data, complex ideas, and how do we study, that learning. And so we took this and worked collaboratively toward a museum exhibit design to invite this sort of meaningful engagement with data visualization literacy. And by that, we mean the ability to read and construct visual representations and make meaning out of the data. And so, why were science museums, as Joe was mentioning, why were they so important in this partnership? First and foremost, these are family learning centers. So we get the whole family unit. So it's just delightful. We thought we were going to study individuals and how they were going to make meaning of the exhibit, but really it became whole families. So you've got varying levels of expertise, really radically different perspectives with parents and young children and grandparents that come by the exhibit. And data literacy, and when you think about where you normally understand this, right, as you engage, it's usually incorporated in data science approaches and a course-like kind of thing. The data set you get, if you remember your statistics course, is very normative. It's a prepared data set. There's no transparency or real-world relevance to this data set. And so by contrast, when you collect data, it's super messy, and we want people to understand the messiness of it, even when they see something really cleaned up. Science museums also provide a unique opportunity for enhancing data visualization literacy by using real-time and sensor-based visitor-generated data. So just as Joe was mentioning that constructionism, we could actually start to get visitors to build big data sets, data point by data point, which is exciting. So this is the exhibit that we started to construct and study. This was called Walk. It was based on a run exhibit that was in place at the Science Museum of Minneapolis, where Stephen had formerly worked. And it was an application of that to start to think about how one would flow through this. And so this was just a really exciting exhibit where, you know, two individuals could compete against each other, and then against, you know, a chicken or a dinosaur or something on the back screen there. And then you can imagine, you know, that you'd see the data, you know, of how fast individuals were running, you know, the pressure plate recording sort of the weight, the beam break recording the height, and data collection was fed to the Macroscope at the exhibit, and then visitors could interact with the screen and start to create their own data visualizations. So this was one way to support data visualization literacy, to help people understand those relationships, and focusing on both individual data records, but also larger trends in the data. Okay. So we worked to kind of create this DVL framework based on COSI's original research, and a typology of 7 types of visualizations relevant for designing effective data visualizations. And so the walk exhibit featured a data station and a walkway for capturing walking times, and a make-a-viz, you know, screen that was here. And participants entered their personal data. They walked down the walkway. The motion sensor recorded the walking time, and they incorporated it into the data. And so the screen showcased probably 50 of the most recent visitor data records, categorized by 3 of the DVL framework typology types, including visualization types, data variable types, and graphic variable types. And this was actually really important. Was, you know, Joe had kind of tipped it, is how big is big data, and how big can the human mind even start to comprehend, especially somebody who's a novice in understanding data visualization. So while we had thought originally that we would create the exhibit as an ongoing set of data points that would just accrue over time, it ends up being too much data for the novice to make sense of. And oftentimes part of what they want to start to analyze is their time and trends of their local visitor, and maybe of their group, how they compared to their sister, how they compared to their father, how they compared to their grandmother, and so forth. So the data visualization, this is a close-up of what you know, folks would see on the screen. One of the things we learned, and Joe and team were just at COSI were just really amazing at this, is just by having a data visualization, it doesn't encourage you to interrogate it. And so we could create, you know, a really compelling design, but these prompts, and we end up sort of just having signs or just different suggestions that could be made. But you know, so we played around with different prompts that would actually encourage that comparison. Like, can you manipulate the data to make yourself look good? You know, can you compare yourself with others? How would you talk about it? Can you find yourself within the data? Can you change your data? You know, can you tinker with it and actually start to you know, corrupt this data? And so all of these tasks around the screen aligned with the framework, and you know, creating tables and scatter graphs and geomaps, and visitors could manipulate the axes on the scatter graph to explore relationships between these variables. And so the geomap visualization, because this was at COSI, defaulted to the Ohio State map, but could be changed to represent data from the US or world maps, showing how fast people could walk from different areas, different zip codes, and what was a meaningful way to even sort that data as we went through. And so you can see here, like the runner could pick an icon, you know, and then they could see their result and the time, the height, their favorite activity, age group, and zip code. This was all surfaced from Joe's earlier conversations with people and the kind of data that they would be willing to enter and relinquish at the start of the project. And these, you know, kind of a mix of qualitative and quantitative variables for, you know, that were shown beneath both the scatter graph and the geomap for the data visualization types. And so visitors could drag and drop variables onto the graphic data variables and to explore different possibilities and consider that not all variables can be represented as graphic variables. And so just thinking about how to map on variables to the different type of data visualization was actually a really strong insight for the learner. Go ahead to the next slide. And across this project, as Joe mentioned, we collected a lot of data. And so we had family and friend groups spanning a wide age range. There are probably about 74 groups, 195 individuals that we tracked for this particular paper, and focused on studying data visualization literacy in this group of from 1 to 8 people. And these, the visitor groups engaged for an average of 7 minutes, on the upper span of about 19 minutes or so. And just remember that the average engagement at a museum is closer to the dwell times around 1 minute or so. And so you can start to see how engaging is your exhibit, because you're competing against all the other exhibits for this time. So that's exciting that we saw that. And the in-depth analysis concentrated on the 11 of those groups that engaged for 8 minutes or more. And then we looked at how they, kind of the learning that was happening across multi-generational visitor groups. And Joe mentioned this, but it can't be understated that we need to think about all the modalities that we can engage data. And oftentimes it's just visual. So the science museums and these other settings just really think about actually the data being driven from our bodies and then entered, allows kids to move and then to create something. But it also allowed them to identify mismeasurements and walking times. You can imagine that the sensor didn't always pick up the runner, or maybe they stepped over it, for example. And so then on the scatter graph, there could be unusual data points. And so that normally as we have big data, we go through a cleaning process, right? We take out all those unusual data points, and maybe that's good, that actually cleans productively, but oftentimes that there's all these outliers. And so when we get these really polished data sets, these really polished visuals, these really polished pieces to actually inquire, we're really missing a chance to sort of educate the general public. So these mistakes are just as important as the successes of entering the data. And so this prompted sort of this reflective need for thinking through things. And then they would suggest design enhancements, or would try different ways of walking and sort of see which one was the fastest. And visitors express this curiosity about the motion sensor, inquiring about how these things work. And so even these early prototypes could be just really, really compelling to start to engage visitors in this larger conversation around data literacy. And when you think about some of the things, they're not always intuitive. So when kids come to the museum, they're used to looking at test scores. So when you think about the x-axis is that from 0 to 100, 100 is best, right? And that's 100%, and 0 is worst, right? And so the fun thing about using an X macroscope in an exhibit like this is all of a sudden we take this, and we invert it. So you can see this little boy kind of pointing to try to understand this little red point here, who's trying to understand that, hey, that's probably a really terrible runner. And actually that was actually one of the fastest trips down that walkway. So the kind of thinking about what could the data interpretation, not just having one true meaning, but just that it's all relevant to the data that's actually being graphed here, and that slower walkers would actually be further along on the x-axis, closer to the 100 time point, and faster walkers would be closer to the 0 time point. And so this sensory data aided in their interpretation, allowed for the parents and the siblings to kind of feel and compare and understand what this looked like on the Make-A-Viz, the X macroscope that was in place here. And so the physical entry not only identified these mismeasurements, but also facilitated engagement with that wide variety of data distribution, and allowing the visitors to physically compare and understand this variety of records. So, as we start to kind of think about things that I would advise, arranging and rearranging the data, being able to not just see the data in one particular way, aids in identifying, single records and finding yourself, but also facilitates comparisons across these data visualizations. What does a geomap tell you that a scatter graph does not, and so forth, and really trying to make that consequential. Opportunities to question the data patterns, to identify these mismeasurements, and address representation gaps that foster this critical engagement that's so important for civic engagement in society. And then data visualization literacy involves both these physical and social activities, as we don't want to be thinking about them in a very didactic and classroom experience. So we need to emphasize the need for designing, group data entry alongside, personal entry, and the physical data entries enhance this understanding and contribute to this intergenerational engagement. Grandparents love seeing their kids participate in this and moving through the exhibit and making sense out of the data. And design recommendations aim to guide the creation of science museum exhibits that promote meaningful engagement with this very, very complex idea. And thank you for your time. I'd be happy that we could share all of these articles are available to freely download on the web as well.
Thanks, Kylie. That was great to hear more about the project and all that you learned as takeaways from that work. Let's see. I'm going to see if I can. Joe and Kylie, are you both able to show your cameras for to be visible for our Q&A session?
Do people trust the machine rendered data visualization or human hand sketches more?
Good question. In that study, we intentionally put errors into the maps that were being created, and the same errors on all the maps. On the hand-drawn, people were more willing to point them out. We found from several that when we said, well, did you notice this? They went, well, I thought it was probably I was wrong in thinking where that road was, or I was wrong where that city is located. So with the computer, they trusted the computer-drawn map. Even with the errors, they were willing to point out the errors to the human drawing.
Yeah,
very interesting.
It is, right? But you can see that there's a human tendency of not questioning something that's highly produced, and
right.
Oftentimes, we so try to get these finely produced visuals, and then we don't realize that we're not actually inviting learners to actually question or think about these kinds of scientific representations.
Yes, exactly. Yeah. And Kylie, what other projects are you working on? How does this data viz project inform your future work?
Oh my gosh. Well, we've just fallen in love with data visualizations in general. One of the recent applications was just looking at how we can think about representing really complex phenomenon in our communities, but also just even at the university. So we like to promote collaboration amongst faculty and, across different schools and disciplines. So I used one of the data visualizations to really show the amount of collaboration happening between the faculty, and it was just really, really telling. So I think we could adapt things into the mundane as well as the future research as well. But Stephen's here, and so it'd be great to have him share a little bit more about the work he's been up to. Hi, Stephen.
All right, so I think with further ado, we'll turn it over to Stephen and get to hear about his work.
All right, thank you for the invitation, and thank you everybody. And so I'm Steve Uzzo from the National Museum of Mathematics, formerly of the New York Hall of Science, which Kylie Peppler mentioned. And I want to talk about a data-driven approach to facilitating open world immersive museum experiences we call formative fugues. It employs a causal modeling to statistically characterize the exploration paths of learners and generates situationally relevant formative feedback. the formative view approach offers a few benefits. Reflection of cognitive and metacognitive load, reduction, excuse me, of cognitive metacognitive load for learners while preserving their autonomy, allowing learners to build a robust understanding of complex systems, and to support research in the process of open-ended learning. There we go. Sorry about that. So this is what Connected Worlds looks like. This is the experience that we were testing, and it's an immersive. For those who aren't familiar with it, it's an immersive public experience at the New York Hall of Science in its landmark Great Hall, which is a very large open space. It allows groups of visitors to explore the coupling of human and natural systems in this a very controlled setting. They have the opportunity to directly embody complex dynamic influences that affect sustainability. The experience responds to visitors' interventions in 4 connected biomes, and they can manipulate the flow of water and grow and cut down vegetation. So this shot shows the actual room, and on the left side there's a desert and grasslands, and on the right side there's a wetlands and a rainforest. And then there are sources of water, including a waterfall, what we call a river valley, and a reservoir, and the water flows out onto the floodplain. You can see in the different habitats, at the bottom of the screen is a representation of the sort of the water table, and then clouds at the top, and the experience shows evaporation happening and clouds moving and water flowing to and from the different areas. So this is this is actually in use. So you can see the scale, you can see the gestures people make to actually control the environment and the flow of water, and the adding and removing vegetation. So embedded in Connected Worlds, there are a number of sort of complex properties we would really like visitors to notice and engage in. It's an open world, so combines the sort of the human social system that is created by the visitors, the groups of visitors, since there are more than one, and they work together to solve problems, and also interacting with the experience. It's kind of a nonlinear dynamic evolution that takes place within the system that changes with all the different interactions. So it's never the same game twice. And the social interactions and the simulation's response to multiple learner interactions don't really add up to a predictable overall system behavior. So here are some of the kinds of things we want learners to engage in, and some of the challenges they face. So while their behaviors are not prescribed or predictive, we want them to look for certain things, and we look for ways to support learning in this environment. So there are multiple pathways to solve problems, and multiple strategies that the visitors can employ at their own will. And we can't always know what those are a priori. The experience also demands that participants attend to local and global phenomena, sometimes at the same time, system responses over time, and understand and assess ways plants and creatures behave. Also requires the visitors to attend to the health of their biome and others, location and amounts of water and behaviors of other visitors, and try to work together to make connections among these phenomena. They have to approach learning in a decentralized and non-reductive way, which does not in any way adhere to the way that they learn in school. So here's the question we came up with: how do we provide formative feedback while they're in the experience, and what would be most useful in this kind of experience to help scaffold their learning. So one of the things we did was have 90 different data streams, different parameters that stream from the experience at 1 second intervals, time-stamped, and we record these for each 30-minute session. We tried experimenting with these data in a lot of different ways to identify how to provide feedback to participants, and more questions arose as we started exploring the data. Mostly because it's an open-ended experience, and trying to identify where to intervene wasn't clear, and what you could actually do to intervene that would synchronize with the way that the visitors were learning as they went seemed very difficult. We really wanted participants to succeed, but we didn't want to impose solutions that would preclude them from exploration. So this is an example of the kind of feedback that a learner-centered expert system would use, with a fixed goal. Success is assessed in terms of alignment to an expert goal, and identifying when there's deviation from the path, and then providing corrective feedback intended to realign the learner to the expert path. We tried that through a few different ways. This is an example which used this Simpson's diversity index to try to provide a visual feedback that let them know what success looked like, what failure looked like, when they were getting to a more successful state. So the lines are all, each one is a session, 30-minute session, and the dark green lines are success. They've reached a sustainable state among all the biomes in the ecosystem, and the dark brown states are sort of where everything is dying, and there's an imbalance among the different biomes. So we found this wasn't particularly useful because even though it could show the outcome of their behavior, it really didn't give them any indication as to what they could do about that, or what they could do leading up to that to actually reach a more desirable state. And they had to define success for themselves. So if the success is everything dies, then that's their goal. That's something that they should be have enough understanding to know how to achieve that, because they come in with particular ideas and they change over time. So what we did instead, we developed a problem space centered rather than learner-centered approach. The feedback is provided by developing a library of conceptualizing exploration maps for visitors' prior interactions, statistically just determine whether they're successful or less successful. And we're calling them fugues. So the fugue is a loan word from contrapuntal music in which musical themes are composed and used as baseline patterns for variation and repetition to create the rest of the music piece. A composer draws from alternative paths in their experience and tries them out in the process of composing to see whether they work. In the case of learners, their actions are open-ended, problem solvings are improvisational by nature, so helping them contextualize their interactions with the baseline for understanding how to assess and make decisions on how to proceed makes sense. And similar to the problem in composing music, we create an improvisational framework for the learner to facilitate their exploration with patterns of behaviors they can use to explore and contextualize learning. The library of fugues is just a set of different ways the problem has been approached in the past. And for visitors to develop strategies, we create these exploration paths for them, which are basically self-similar patterns that represent various methods to solve the same problem. So for the sake of simplicity, just what fugues are, it's a procedure represented by a series of actions that lead to an endpoint from an initial state. The transformation between the states is unspecified by the problem statement, but the terminal state the learner is trying to attain, such as increasing or sustaining diversity, or less ambitious goals like having more of a certain kind of creature inhabit the biome. Then through the library to suggest to the learner what they can adopt in terms of a procedure develop a more successful path, or change what they do, or find a new way to improvise a solution to the problem. The advantage of this is, of course, is you can do it potentially in real time. So if we map this process out in form of a causal model, it's fundamentally a directed graph. In this illustration, the yellow nodes represent the actions of the learners directly, that they directly control. The green nodes represent systemic actions that are not directly controlled, but are triggered by other actions of the learner. And importantly, what's shown in blue, which actually here looks gray, are the human-derived outcomes or effects. These would allow us to evaluate how well learners are doing, and whether to help provide explanations to why plants might be dying, why a biome fails to thrive, why they might run out of water, and including these kinds of feedback to participants to give them a better understanding of what's going on in the experience, because they have to attend to all these different things at the same time, and identify what strategies might be successful as opposed to unsuccessful, and what level of detail that they might need to determine how to be successful. And so capturing these interactions is what leads us to be able to create these fugues. So here's how the causal model is used to construct fugues. So over here on the left, there's a tree of causal connections, which is generated by the data that streams out of the experience, but there's way too much detail, so we have to prune that into the ones that are most successful. So the darker lines are things that are more successful or more repeated by visitors, that lead to successful or toward successful states. Then we use the branches to provide sequences of the data that can be analyzed to determine which ones will be usable as fugues, and then employed as what we're calling explanatoids after Crowley, that can be relevant to the situation. So the idea is to get these sequences of events in some form that the explainer actually can use to help facilitate the experience and help guide the visitors when they're in situ, when they're in the experience and actually working on solving problems. So this is one of the forms that these took. We actually created these cartoons which are actually just very short video clips that were derived directly from the experience. And part of this is to overcome language barriers, but also to enable visitors to build their own pathways and collaboratively work together to find a solution and minimally disrupt the experience. So we built this as a sequence. It's a logical sequence that visitors could use to actually think about how to get to a successful state. And we then tested these with visitors in the experience. So you can see on the left here, we set up tables with iPads with these cartoons on them, and then we had visitors have conversations about how to sequence these cartoons to get to the state that they wanted to. And when visitors were asked to tell a story about the sequence they created, they were able to identify things like causal chains, telecoupling, and feedback loops, and other sophisticated ideas that were not they couldn't think about when they were actually in the experience. So while there's a lot of data we have to analyze, because you can see this is group 57. So we did had a lot of these conversations, and we haven't really mined the data yet. But just knowing that they're starting to talk about these things makes it a promising idea, and possibly a way, not in this form necessarily directly, but finding ways to build a facilitation experience that will help the visitors scaffold their experience and understand the sort of systemic ideas that we want them to glean from the experience. In terms of how I see this as a macroscope, this is a human in the loop process where we basically build these models out of the models, the causal model. We derive these fugues, which are then used to create these, in this case, these cartoons, but it could be things from live demonstrations, or it could be verbal. We haven't tested them to that extent yet. We're still in very early stages, and then use that as feedback that helps facilitate the group interactions. And that's really all I have for now. These are the other people that have worked on this project. The main person who did most of the work is Aditi. Layla Lyons was originally the PI on the. I became the PI when she moved on to the National Science Foundation, and Edda was a very diligent research assistant in all of this, and she actually created the cartoons. So and did it in one day, which was very very helpful to getting the experiment going. And then these are just the sponsors for the work.
Thanks, Stephen. That's great to see more about that Connected Worlds exhibit. I wonder, I know we're close to the end of the hour here, but if Kylie and Joe would like to pop on too, I guess maybe I've got one question for you. And then after that, if anybody watching would like to put questions into the Q&A, and our panelists can continue to answer those after the end of the hour. Let's see. I wanted to pose the question that Joe did in his original talk. We can address these complex intersections of technology and in public places using macroscopes, but should we? and I guess you guys have all shared some interesting insights in terms of ways to engage people with data visualization. If we did sort of a lightning round, what kind of what would you recommend from macroscope makers or data visualization folks who would like to encourage people to engage more with their work? Do you have any takeaways from the public arena?
Well, I would encourage us to look at the gamut of pathways into learning that could ideally get people to start to dig into data, see themselves in data, and in a lot of different kinds of environments. I mean, Connected Worlds is kind of an extreme version of that, and a very challenging one. But there are lots of things from very simple to the very complex, which some of these studies that Kadi and others have done. So that would be my take. Think big, do a lot of things.
Kylie, do you want to go next? Do you want me to?
Sure. One of the simple things is just thinking about not overwhelming, that initial interaction and layering. So, just finding ways to start with a few data points, kind of mimicking that portion there, finding multimodal ways of thinking about generating that data, and generating data from everyday experiences. The run/walk exhibit is a really nice example of that. But data comes from everywhere, and so just really creating a very open invitation so that people can start to see what that's like.
Thank you.
Yeah, similarly, the human mind is wonderful. It can understand really complex things, but not if you look at it as a complex thing. You need to build into it. So reveal the complexity in these visuals, helping people take it apart and seeing it, and then putting it together to make meaning. When we look at the thing that's done, it's often so beautiful and so overwhelming, we can't take it apart. So revealing complexity is one of the things I strongly encourage in informal and non-formal learning spaces.
Great. Let's see. I think we're ready to pass it back to our to the studio, so to speak. But I wanted to thank each of you for joining us today and sharing with us some of the insights that you've all drawn from working with the public in public spaces and in such a complex arena, and to bring us a perspective that's a little bit different than some of the rest of the folks that we talked talk with who are coming from the data visualization side. So it's a really nice framing and a nice beginning to the discussion that will continue to unfold for the next 24 hours. And invite you to stay and continue to interact in the chat if you would like to and if you're able to. And I'll turn it over to you, Kadi, for this next hour of Macroscopes.
Thank you.